Hey y'all, today we are going to talk about proportional relationships and its association with slope. So let's go ahead and turn in our textbook workbooks to lesson 2-6. Should be page 123. Let's go ahead and start with the first problem, the solve and discuss. In the fall, Rashida earns money as a soccer referee for her town's under-10 soccer league. So far, she has worked 5 games, so that's probably important, and has been paid $98.50. Okay, I'm going to underline that because it's probably important. She will work a total of 14 games this fall. How can Rashida determine how much she will earn refereeing soccer games this fall? So let's go ahead and let's set this up what we know. So what do we know so far? We know that she's worked 5 games, and we know that she has been paid $98.50. And it says she's going to work a total of 14 games. Not 14 more, but a total of 14. So we can set this up with money over item to determine how much each game is worth, then multiply that by the 14 games. Or you could set this up as a proportional relationship. So if you understand proportions and crisscross multiplying to solve, this is how you would set it up as a proportional relationship. You would need to make sure that you have your money, $98.50, over 5 games. And we want to see how much money we would make, so we're going to put an X, because we don't know, for 14 games. So you would set this up as a proportional relationship, and you would crisscross multiply. 5 times X is 5X. Then you would multiply across, and you would look at $98.50 times 14. Go ahead and grab your calculator. 98.50 times 14. Okay, so that's 1379. So you would say equals 1379. And then you would divide by 5 to solve for X. Divide by 5. So go ahead and take your calculator back. Divide that number by 5. 275.80. Okay, so equals 275.80. Now, this should be a repeat of things you learned in 7th grade. You can also do this another way. If you're confused about proportions and setting up the proportions in the correct manner, you always want to make sure that you have the same thing on top on both sides and the same thing on bottom on both sides. So that's why I have money over days. I don't know how much money, but I do know 14 days. That's why I set it up in that particular order. If you're not sure about proportions, you can always break this problem down. And if you break it all the way down, then you would multiply it back up in the end. So let me show you what I'm talking about. We know she has earned $98.50. So that's the first thing that I'm going to start with, $98.50. I know that she has already worked 5 games, so I'm going to divide that by 5 games. Now, I can find a unit rate. So let's break this down. 98.50 divided by 5, because that's how many games she has worked so far, is 19.70. So she makes $19.70 per game. Now, if I know that that's my unit rate, I'm going to multiply it by 14 because she's going to work 14 games this fall. So that's my unit rate times 14. So we're taking that unit rate, $19.70, times 14 games. And there you go. You have the same answer, $275.80. So you can work this either way. You can work it as a proportion, or you can work it as a unit rate. I will tell you, we deal with a lot of unit rates in 8th grade. So this would probably be the most beneficial way to break things down in 8th grade, because a lot of your problems are going to ask you for unit rates first. Then they're going to ask you to multiply it back up by a certain amount. So let's go ahead and flip into our lesson. Let's look at the next page. Understanding slope. So we've already started talking about slope a little bit. If you are unsure about this, please go back and watch some of our other videos. We have a video from Friday, which was our 2-5 lesson. We also have some growth lessons that we did, day 1 and day 2. Go back and watch those, and it will help you become more familiar with slope. So let's look at this first problem. Maya and her father were building a treehouse. The roof will have a 9 to 12 pitch. That is for every 12 inches of horizontal distance. So for every 12 horizontally, it's going to rise 9 inches. So every time her roof goes out 12, it's going to go up 9. How can Maya determine the height of the roof at its peak? So she wants to know the height of this roof at its peak, all the way up here. What could she do? She could set up a table, and every time she has a horizontal distance of 12, she could go in increments of 12. Notice that she goes 12, 24, 36, 60. So here she's going in increments of 9, 18, 27. She's going in different increments to be able to determine how tall this roof can be. So what if she were to take these as points and plot these points on a table? On a graph. So she is actually plotting them. Notice these little triangles here. This is something new. We did discuss it a little bit the other day. They're called growth triangles, or you can sometimes hear people say slope triangles. So the slope of a line is always rise over run. How much did I go up for every how much did I go over? So notice this triangle right here. How much did she go up? 9. How much did she go over to get to that 9? 12. So that is the slope of her line. The slope is the steepness. So that's how steep her line is going to be, or in this situation, her roof. Let's actually try something. Let's look down here. Jack graphs how far he plans to bike over a 3-day charity ride. Find the slope of the line. So slope is basically our steepness, and it is breaking something down to its unit rate. How much does it happen each time, depending on the situation that you're talking about? So slope is our rise over run. Notice they already have the triangle drawn for you. If you don't know how to draw the triangle, you go from point to point. So you're going to go up, that's your rise, and over is your run. Notice I went from an exact point to another exact point. You'll notice people do triangles on either side of the line. That does not matter. The triangle can be on either side. It does not matter. What does matter is that you put it in the correct formation in your fraction. Rise is always on top. Run is on the bottom. So how much did you rise versus how much did you run? So this graph is actually going by tens, so I'm going to fill in what's missing just so I don't make a mistake. So it starts at 30. So if I go from 30 to 60, from 30 to 60, how much did I rise? How much did I go up? How much did I rise? 30, because from 30 to 60 is 30. So I'm going to put that in my rise. And you'll notice, even though they did the triangle on this side, they still rose. They went from 60 to 90. From 60 to 90 is still 30. Okay, let's see how much they ran. From this line right here, that dot, so that's a 1, going to this perfect dot is a 2. So they ran from 1 to 2. How much is that? 1. So they ran 1. Well, what is 30 divided by 1? 30. So the slope of this line is 30. So how does the unit rate and constant of proportionality relate to slope in this particular situation. So this is basically telling you your days down here and your miles up here. So every day, Jack ran 30 miles. Excuse me, he rode 30 miles because he is what? Biking in this problem. So one day, he went 30. On day 2, he went another 30 to get to 60. On day 3, he went another 30 to get to 90. So for every 30 miles, it was one day. The slope of this line is 30 because it's my rise divided by my run, rise over run. Go ahead and look at a few other problems in your book. I want to talk about one more thing before we get started with our actual lesson on our own. Notice that this graph is going up and this graph is going down. You always read graphs from left to right. And whichever way your line is going, that will tell you if your slope is positive or negative. This line, if I'm reading it from left to right, I'm going to trace it with my finger, left to right. That line is going down. So I have a negative slope. Let's look at the second one. From left to right, I'm going to trace that line. My line is going up from left to right. That is a positive slope. So you always find lattice points and you find your rise over your run. So there is a lattice point. Now this one did not rise. This one fell, which gives you another hint. It's negative. And then it ran. So you're always going to see what happened and how much did it go down or up. In this situation, it goes up. And then how much it runs. So you're always going to write your slope as rise over run. Notice on this graph, they took a point in between. It was not a perfect lattice point. That can happen at times as long as the information is given to you. Use those 2 points. Now, you can also set up your rise over run if you're only given 2 points. You can set that up as y minus y on top and x minus x on the bottom. We are going to get into that a little more as we go. Let's go ahead and flip the page and look at a few example problems. So look at this key concept at the top. Slope is always rise over run. It's the change in your y coordinates over the change in your x coordinates. And like I just said, y minus y over x minus x. So let's draw some growth triangles on this practice example problem. How much did this line rise? Don't say 1 block. Look at your actual increments. It went from 15 to 30. So how much up is that? 15. Then it went over and it ran. So rise is on top. How much did it run? From this line, which is a 1, to this line, which is a 2, is 1. So 15 over 1. One ticket costs $15. The constant of proportionality is 15. So your rise over run is 15. Your slope is 15 on this line. Let's try one down here together. These model airplanes, how much rise and run do I have on this particular line? I'm going to draw my slope triangle or my growth triangle, and I'm going to see what happened. So I went from a 5 right here up to a 10. So how much is the difference of 5 to 10? 5. Now let's look at our run. So we rose 5 over how much did we run? Let's look at our actual run. So we go from this number right here is a 3 all the way over to this number is a 6. So how much is it to get from 3 to 6? 3. So 5 over 3. Your slope for this particular line is 5 over 3. And you can leave that as your slope. Go ahead and start working on your practice and problem solving. After you finish the do you understand, do you know how, and check your answers with mine. Hope this helps. Y'all have a great day. Bye.